Hi, my name is Shemra Rizzo, and I am a senior data scientist at Genentech. My most recent work has been on studies of COVID-19 and using data-driven approaches to evaluate eligibility criteria for cancer clinical trials. As a data scientist, I use Python every day for data cleaning, data manipulation, data analysis, and machine learning. Today, I will be talking about my experience mentoring my son who started learning Python during lockdown, something that to my surprise proved to be a very rewarding experience. Do you remember what it was like when you first started to code? Perhaps you imagined it would go like this, but quickly felt discouraged and frustrated? I know my own journey definitely felt like this at times. If you have been programming for a while, what would you say to yourself if you had a chance to go back in time and talk to your beginner self? Unfortunately, traveling back in time is not possible, but we can always share our experiences and advice with those who are just starting. And this is the opportunity that I was given. Okay, so a little bit of context. Last year, as we all know, COVID-19 was officially declared a pandemic. In California, we received notices to shelter at home on March 19. Being under lockdown affected everyone in our family differently. My oldest son, in particular, had to finish his senior year of high school online. Classes became easier, but without the social component, it was a really sad way to finish high school. I personally like college much better than high school, so I cheered him up by telling him that the best was yet to come. Unfortunately, this also didn't happen. The pandemic got out of control and many universities became remote for this academic year. Sheltering at home, being in lockdown, was the right thing to do in a pandemic from a public health and population perspective. But at the personal experience level, like in this case, it sucked. So, in the fall, my son started college online. He has actually never been to this campus. His intended major is computer science. Professors and TAs are all making a big effort to make it work, to provide the material and the knowledge. But missing out on the social aspect is what makes the experience very rough. Based on my personal college experience, the academic and social aspects sometimes go hand in hand. For example, I have very pleasant memories of working on homeworks and studying for exams until very late at night with a close group of friends while going through some of the hardest classes. I remember explaining concepts that I understood to others and also having things explained to me. This dynamic was particularly important for me at the beginning during my first 2 years of college. So I was sad, and I'm still sad, that my son didn't get to experience this. One of his first classes was Python 101. That wasn't the exact name, but it effectively is what it is. A class meant to showcase the language capabilities and bring real challenge to the students. It was meant to give them a taste of real programming by having them solve problems and projects that on one hand cover all the Python fundamentals, but also had a clear purpose like building a Sudoku solver or take derivatives of mathematical expressions or perform motion detection, etc. It was hard. From the Slack and Discord conversations, it was clear that most students were struggling. My son started his class doing stuff by himself like he had done during high school. But after a few homeworks, it wasn't going so well. He was crushed. His efforts felt like they weren't enough. Without peers to commiserate, his confidence tanked and his mind ran to worst-case scenarios. Why am I studying computer science? Clearly, I am not good at this. I should be a writer or a game designer, and he started reading on how to switch majors. Does this sound familiar? It sounded familiar to me. When I was studying my PhD, one of my hobbies was daydreaming about quitting and about having alternative careers that were as far from STEM as possible. I actually bought and read books on how to be a screenwriter, an illustrator, a children's book author, and a photographer. I didn't quit my PhD. I succeeded and even won financial awards to support my dissertation writing. I didn't want him to quit his major, at least not at this point. I knew I could definitely be of help and that I could have a positive impact in his trajectory. After all, every day for me starts like this. The areas I saw I could clearly help were on how to approach problems and on setting realistic expectations. I wanted to be a mentor that would guide him to success in this particular class. So we set a routine to meet 4 times a week to talk about his Python programming. We would review what he was stuck on and discuss how he would get himself unstuck. In our conversations, we kept converging to the following themes. And I will go one by one. So the first one, programming is not memorization. Google is your friend. Being new to Python and to programming, we clarify that programming is unlike any of the other classes or fields of study. Sure, at the beginning, you might need to memorize some syntax, but the truth is that even this happens organically. If you are consistent in your programming practice, the more you use it, the more familiar it becomes. Consistency is the most important thing when learning a new language. This is true for any natural language, including French or Spanish. In our case, this was easy, given that the class comes with a prefix schedule of homeworks and projects. But for others that are learning Python on their own, like I did, it is important to commit to practice daily. Second, Google is your friend. Googling for answers doesn't necessarily work in other classes. For example, in math, if you are trying to prove a theorem, you are armed with the theorems that you've learned so far. And then you have to come up with creative ways to connect them to build your proof. If you are stuck, it is very unlikely that a Google search could help. In programming, as you are working on new challenges, there will always be coding details that you either can't remember, you can't quite figure out, or you simply don't know. Luckily, Python is an extremely popular language that has been around for around 3 decades and is open source. There are extensive resources, documentation, forums, and the answers to any question are almost always one Google search away. I was very open with my son about how much I rely on the community, the resources, and the support online every single day to get my code up and running ASAP. Here are some of the things that I Googled this past week. Python pandas cross-tab with missing data. Python print large output without ellipses. Python remove multi-level index after pivoting table. And lots of daytime manipulation questions. I also Google every weird error and warning that I get. My Google searches usually lead to the popular community-based forum Stack Overflow. Sometimes I find the answer to my question right away and I copy-paste it. The few times that I couldn't find my answer, at least I got some useful ideas. All right. So now, don't jump straight into coding, sketch first. Once we got comfortable with not knowing, we could look into solving problems. Except that first, I insisted on not coding right away. Not yet. Sketching the problem and solution in a piece of paper is something that I have found extremely useful every time I needed to solve a problem, in any technical field that I've been a part of, in physics, in math, in statistics, and in data science. So while it's very tempting to jump into coding, there are several advantages to spend some time at the beginning creating a visual representation of the problem and the solution. First, it can help you define the problem clearly to yourself. Sometimes you think that you get it from just reading about it, but once you draw it, you realize that there are some nuances. Second, it facilitates brainstorming solutions and allows you to visualize different approaches to solve the problem. Sometimes, it also allows you to see patterns. And it definitely saves time because it avoids writing a bunch of throwaway code. My son assumed that this was some sort of beginner's technique, but it isn't. I don't sketch every time I clean data or run a simple model because I've done it hundreds of times, but I still find plenty of opportunities to use my scratch paper. Recently, I needed to develop an algorithm to identify hospitalizations out of medical records. If you have worked with medical records before, you know that they are very messy. One thing that I found is that there were sometimes overlapping records for the same patient. So my objective was to extract the start and the end date of the hospitalization. And with a simple sketch as this one, the one in the top, I was able to visualize in one spot all of the possible overlapping scenarios that my code needed to account for. And that way, no single case escaped me. Sketching also allowed me to have a plan for scenarios that I had not initially considered. For example, if a patient spends the night in the ER, does that count for the hospitalization length? If I see a one-day gap, does that really mean that they were discharged and readmitted within 24 hours? And what would I do if the end date is missing? Well, I would pull information from other sources that give me evidence of presence in the hospital on consecutive days, which is a whole other algorithm. So I was able to answer this and other questions first in my sketching before jumping into coding. Storyboarding or sketching is not an easy habit to establish because it can feel like you're wasting time, particularly when, like in homework, the time is ticking and you need to submit in a few hours. But it is an efficient way to approach solving a problem or building anything. This approach exists in many fields and industries. In the entertainment industry, there is storyboarding before animating. In app or website development, there is storyboarding of the user experience. In architecture and construction, there are blueprints before building, etc. It is ubiquitous because it works. Okay, next is making mistakes is normal. Debugging is not a sign of failure. Okay, so now we have our solution sketch with perhaps some pseudocode here and there. We can jump into coding. You write the code, and the first thing that happens is that it doesn't work. Of course, when solving these problems and in these homeworks, most of the hours were spent looking for the part that wasn't working. These were some of the sentences that I heard. This is not the right output. The code is not doing anything. I can't find what's wrong. No matter what I do, it still doesn't work. Frustration and rage are totally normal emotions, especially when you have stared at the code for a while and already made all the changes you can think of. So here is how we systematically approach it. Is Python giving you a clue about what the problem is? Sometimes it explicitly tells you what is wrong, or it may point at the line where things went wrong. If this is not the case, then look for small common errors, like using an equal when you mean to use double equal. Also, are you calling the functions by the right name? Next, still no clue? Use print statements. Sometimes this is really helpful, like it can help you narrow to the section where the bug is, but other times it backfires. For example, when my son put a print statement in a recursive function, he got inundated with output and it was really hard to make sense of it. If this happens, Minimize and simplify. Feed your functions with the most minimal input possible to reveal the bug. If it's a long function, break it into two and test them separately. Continue to break the code like Lego pieces into smaller and smaller components that you can test separately. And if all else fails, can you get a second or third set of eyes to look at your code? This actually happened during the last homework when students were solving the queens problem. This is a problem where you need to put queens in a chessboard in such a way that they can't attack each other. So sketching of the solution was done, writing the functions following that solution was done, and everything seemed fine. But weirdly, it wasn't working in all cases. It worked for 4 or 5 queens, but it didn't work for 6 queens all the times. My son was very frustrated. This was very weird, and he thought he had tried everything. It was time for the extra set of eyes. One of his classmates offered to help. He took one look at my son's code and immediately knew what was wrong. In the step when you are looking for a new move, a new position to put the queen, and it proves infeasible, you need to replace your board with its previous configuration. The board was saved as an array, and my son had used the equal sign to restore the previous configuration, but this is an assignment. What he really needed was to make a copy of the array with NumPy copy. Once that was fixed, it ran beautifully. Okay, the next is make sure your code does what it's supposed to do and that it's readable. All right, so now we have code that works. Do we submit? Not yet. 2 things to consider. Does your code really does what it's supposed to do? And can somebody else read it? I mentioned that the first homework didn't go very well. In that homework, students were asked to write a variety of functions. And to grade 300 students, automatic tests graded the scripts. Students could see the test because they were part of the homework. My son had written the functions and those functions had passed all the tests. But of course, when grading happened, there were additional hidden tests. And these were the tests where the functions fail. This was an excellent lesson and another case why sketching is very helpful. Those tests cover the least obvious cases, edge cases, rare cases. When you are designing your solution, you need to think of all of those. The first time code worked, we practiced trying to break it. Throw at it the weirdest scenarios you can think of. Something as simple as what happens when you feed your function a negative number. And then you can truly be sure that it's doing what it's supposed to be doing. All right, so finally your code works and is doing what it's supposed to do. Can somebody else read it? Would you be able to come back to it in a week or in a year and understand it? I learned this lesson the hard way as a beginner. I had done data analysis and that included lots of models and simulations. And then 1 year later, I was asked for more simulations and more analysis. So of course, by then I had forgotten all about the project. I opened my code only to find that despite having written some comments, it was not enough for me to figure out what past me had done. It was painful and incredibly inefficient. My son sometimes would feel that if code works, I must submit ASAP and move on to the next thing. I understood that. It could feel counterintuitive to spend this extra time making sure the code is easy to read and understand. But it is an investment and ultimately a requirement to be a successful programmer down the line. when you need to work in teams and share your code and update each other's code. So whenever time was available, I encouraged him to do the following. First, change your variable names because names like dummy, recursion, other variable, and previous are not good names. Second, add docstrings to all your functions. Add comments and make sure that they are complete sentences. Next, can we tidy up some things? That conditional statement that is 4 lines long, is there a way to rewrite it in a simpler way? Even if it means adding a few more lines, it is worth it. And finally, can something be written more efficiently? Are those 3 nested for loops really necessary? This part can be time-consuming because it requires going back to the drawing board and figuring out a different way to reach the solution. But if time is available, it's worth doing. Okay, so finally, don't learn alone, find a mentor, and find a community. As a wrap-up, I think the final lesson was to not learn in isolation. It is much more fun and productive to learn alongside others. If you are learning, find a mentor or find a community or both. Python has a very large community online, and in general, it is easy to find people to interact with. When you're taking classes, finding a community is a bit easier because you are already surrounded by other people that are also learning. And there are plenty of classes online. If you are not part of a class and are learning Python later in life and by yourself like I did, there are plenty of ways to meet others who are passionate about Python, like this conference, and also local meetups. Finally, you can create your own community, and it doesn't need to be big to be extremely beneficial. Currently, I have these 2 friends and colleagues, Kelly and Ryan, who are my go-to people for all things Python. We interact frequently and help each other when we are frustrated or are encountering a weird problem. We share new things that we've learned, and a few times, they have been the second set of eyes that I really needed for my code. A few times, we have been lucky to work on projects together, in which we pass the code around. One starts it and the other one finishes it. It is fantastic, and it makes the work really enjoyable. So to wrap up, I'm very happy to report that over the course of his class, my son grew closer to his classmates via Discord. Students became more open in their struggles and generous in their help. I am in awe at their resilience. Despite the distance, students have managed to connect with each other. It is not perfect and doesn't replace the in-person interactions, but I have witnessed their eagerness and their genuine effort to create community. My child succeeded in his class. He got an A, and his confidence grew and now feels ready to take on more advanced courses on his own. My favorite part is that we grew closer because of this experience. So, if you are an experienced programmer, I hope you feel inspired to become a mentor, to support others and share your own experience, particularly with those that are starting their programming journey in Python. Thank you.